So this red light, that's occasionally strobing and overwhelming the camera. I've got this to go on the back of a little 72cc bike I used to go to work and back on. I don't really use it a lot in the year to go anywhere on, just apart from work. But this time of year, the weather's getting pretty shit. Roads are getting icy and muddy. If I want to go out to the sticks to see some friends, I generally take it, simply because it's nice and light, so it's easy to hold up. And if you do drop it, it doesn't really matter, because it's just a cheap Chinese piece of crap and it's easy to pick up again. So, problem with it being, because it's slow, you get car drivers come barreling up behind you. They either just expect you to get out of the way. I actually had last year, I was coming back from getting a new helmet. I had a bloke in an HGV come off a roundabout behind me, and he just sat beeping his horn, just expecting me to get out of the way. Then he just pulled out alongside me, forced me off the road, and fucked off the bell end. But so anyway, I've also been knocked off my bike twice. I've been rear-ended. Once I was sat at a roundabout, once I was sat at traffic lights, and the famous, "Oh, sorry, mate, I didn't see you." You think, both times I was wearing a bright green, like, high-vis jacket with reflective strips on it. It was daylight, and it's not like I'd come to an emergency stop. I was sat there waiting, and they've just ploughed straight into the back of me. So you see a lot of accidents on roads, people hitting the backs of even fucking cars and lorries. So, you know, on a motorcycle, you've got to be aware. So I've been meaning to put some additional lighting on the back end. Now, red lights are all right, but a constant red light doesn't really stand out. But the human eye picks out movement. So, you know, you can do it. You can you look at a stick insect or something that's really camouflaged on a piece of foliage. It's really hard to see, but if it started moving, you'd pick it up dead easy. It's just the way the human eye works. It picks up on movement. So a flashing red light, even with a slow flash like this, is far more eye-catching than just a constant red glow. Now this thing, it says on the listing that each one of these are 5-watt LEDs, and it is incredibly bright. Now I measured the current, a 15-volt power supply I've got plugged in down there. It was drawing about half an amp, which, so it's, give it losses about 7 watts. So let's say each one of these LEDs is probably more likely a 2-watt LED, and to be honest, they're quite small. So let's say they're probably more 2 watts. They might maybe be 5-watt rated, some sort of short-term peak power thing, but I would say they're probably 2-watt rated. And yeah, I've seen 5-watt LEDs, and these aren't 5-watt LEDs, but let's call it about 6 watts maybe of actual lighting power, which from LEDs is still a lot. That bulb over there is about 6 watts. This one up here is 6 watts. So now it is immensely bright, and I mean it's very directional, and it is retina burning bright. If even with these quick flashes pointing at my face, I cannot see a thing. It just completely blocks the field of vision. You have a couple of flashes in your eyes, and trying to even put like resistors and stuff in this board, you can't see the holes. Everything just becomes this big blackened, burnt blur for 5 minutes until your eyes re-catch. So this mounted on the back of my motorcycle, facing towards cars behind me. There is no way, first of all, they're not going to want to sit up my arse end, because if they get close to the back end of this thing, it's just going to be blinding them. And secondly, there is no way they are going to say they didn't see me if they was coming up behind me. So yeah, I'm just making this video because I'm just messing about with drivers for this. Now, I was toying with the idea of programming a peripheral interface controller. I was thinking that I could have it so, I've done it before on the back end of the lights when I did an LED conversion on a little 125. And the PIC, it knew when the lights was on, it knew when the brake light was on. All that was doing, they were just a cluster of normal LEDs. It was driving them, pulse width modulation for lights, and putting them on for brake. But I was thinking with this, I could make it multifunction. I could do something like program the PIC so that if I turned the light switch off, so it would sense that the light switch wasn't turned on, there'd obviously be a mains constant power feed from the 12 volt to the PIC. And then like press the brake. As I dabbed on the brake lever, it could set this in different modes. So it could just set it to a real dim, constant running mode where it got bright when I pressed the brake. I could set it so it was like in a brighter fog light mode. And again, there's so much reserve luminance left from this thing. Even if it was running as a fog light, quite bright, you could still make it come bright when you press the brake. And I was thinking, like, if I wanted to, I could cycle it through various flash modes, which is easily doable. However, like the saying says, keep it simple, stupid. So I found PICs, you're going to need a voltage regulator, it's going to need a board, you're going to have to protect it from damp. Whereas something a bit more basic, like a good old-fashioned 555 with a emitter follower output transistor, is a lot simpler. This is just the basic 555 circuit, but rather than the A-stable, if I draw this out a second, so give me a second. So the normal 555, I've not bothered putting the extra connections on here. This is just for timing components. 7 is discharge, and 2 and 6 are threshold and trigger. So what would normally happen is the discharge transistor, when you turn the 555 on, is open collector. So this resistor to the power rail will draw current through this resistor to the timing cap. When it gets to 2/3 the supply rail, so say it's at 9 volts, that would be 6 volts. 12 volts, it'd be 8 volts. So yeah, basically it's not a fixed voltage, it's just 2/3 of whatever the difference is between VCC and 0 volt. So when this capacitor charged to, so on a 12 volt system, 8 volts, the discharge transistor would turn on. That resistor would obviously be shunted to 0 volt via the discharge transistor. But this capacitor will then discharge through this resistor into the discharge transistor. When it gets below 2/3 VCC, so that would be 4 volts, the discharge transistor will turn off and the whole thing will just repeat, repeat, repeat. As this is charging up, the output goes high, so it turns on. As this slot is discharging, the output goes low. It is still actually on because it will sync or source current. However, if you was using it to pull something high, then in the on period it would be lit up, say an LED, or you could do it the other way around, and in the low period it would light the LED up. The problem with this one is that it can be a bit awkward to try and get the timing you want, because in this standard mode it's impossible to get it to turn off for a longer period of time than it is on if you're trying to drive something with the output pin turning low, because to turn the 555 off it has to charge up through these two resistors. However, to turn it back on again it only has to discharge through this one. So the discharge time will always be quicker than the charge time. Now when you want to do a basic circuit like I've got, so this is my LED light, here's a transistor coming straight off of the output pin. Rather than using the discharge transistor and going to the power supply, if you put two diodes in different directions going to two different value resistors, so as the output goes high, this is only a my 110K, this is a 4.7 microfarad capacitor, so it will charge up in about 30 milliseconds, so it'll only be on for about 30 milliseconds. And then at 220K it goes off for, it's about 7 seconds or something. No, not 7 seconds, 3 seconds. Let's have a look. I can't remember, I did do the maths. Anyway, it's, yeah, nowhere near that long. It's probably flashing about once a second, you'd guess, wouldn't you? Something like that. What are we on? We are on 200 milliseconds per division. I don't know, whatever it's flashing. It's a nice speed. I played about it some values and it's worked out to be quite a nice speed. So yeah, when the output turns high, it charges up through a 10K resistor and a 4.7 microfarad capacitor. Turns off, it's a quick burst on, then it's a slow discharge through a 220K resistor into this capacitor, and it will just cycle. So if you can look at the oscilloscope, so that's the little peaks are how long it's on. So you can see it is maybe about 10% of the time it's on. It looks about 10% of the time it's on. So that is just a real quick, super quick flash. If I try and speed the scope up, yeah, let's get one on the screen and stop it. So that's 40 milliseconds per division, and it's taking up about just over a division, so about 45 milliseconds it's on for then. I can't bother to... It's been ages since I've done a screen capture on this scope, and to be honest, I can't remember where the menu is. So here's the off. So that's 80 milliseconds per division. I actually have to look on my phone. I can see it better on my phone. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So not quite 10. About 750 milliseconds off. About 40 milliseconds on, then 750 milliseconds off, which is, yeah. The maths never quite works out on these because electrolytic capacitors are a bit leaky and stuff. And obviously I'm going through diodes, different rates of current. They'll have a slightly different forward on voltage and on resistance and stuff. So, but yeah, so if I pull out one of these caps, you can see it just, because there's now no timing cap anymore, it's just cycling rapidly as fast as it can. It's making noise. It's actually still... I mean, you can see it's barely on 50% of the time, and it's still very bright. So I can change that one out for this little 100 nanofarad cap. Going to get it in. Come on, in you go. Oh, hang on. Yeah, wrong one. Let's go there then. So all of a sudden, that's now running... Even that would be, you generally class that is too bright even for a brake light, and that is running. And you see, look, that's the, so this thing has got some serious power. And I'll do the old, probably won't get it on the camera because the frame rate will be wrong, but you can do the old make your finger look stationary in the flashes trick. So yeah, that, where's my horizontal menu? So yeah, again, maybe 10%, if that, on time. Now this actually has a little constant current driver in it. I'm toying with taking it out and putting a resistor in its place. If I'm going to build a circuit here, because this, first of all, it says it's waterproof. It isn't. There's no rubber seal around here, and there's a big hole in the back there and another loose hole where the wire goes through. So I'm thinking I might shove a load of silicone around there, shove some silicone in there. And if I take the circuitry out of there, I'm never going to have to try and take this apart again if something goes wrong with it. So I think I'm going to probe the voltage across the LEDs when they're on, measure the current through them. I've already measured about half an amp, so maybe 450 milliamps or so is actually going to the LEDs. Some's going to be getting lost in the driver. Probably, I should doubt I'm losing 50 milliamps of current is wasted energy in the driver. But yeah, so I'm thinking I'll just put a resistor on the board. I'll make this circuit up for putting it in the bike somewhere. Put a resistor on board. So I still have the option. I could put another 555 in here rather than just having a single flash. If I wanted, I did it before many years ago when I first started playing around with 555 timers. They're a fantastic little thing for like kids and stuff to mess around with for electronics because they're so flexible and so easy to use. I'm thinking I might, no wonder I'll never get anywhere, still on fine. So I'm thinking I might, I could put another one in, so rather than just having a single flash, I could make it do so like, it could do a, as one went high, it would turn the other one on for a fraction of a second. That one could be set to do 3 real quick flashes or so, and then this one would turn off. So you could have it, so instead of coming on one flash, it would go flash a flash off. Flash a flash off. It's all playing around. Of course, I can put a diode in the output emitter leg of this transistor, and I can just put a resistor to say the brake light feed. So I have it that when I pull the brake, it comes on permanently at lower brightness. Or I could, again, I've got the option of putting another 555 on here, which would come on when I press the brake light one, and that would just be on a faster flash or just a constant pulse width modulation to just make it a much brighter light. Because I think, to be honest, any way I have this on my bike, if I have it on at full brightness, it's just stupidly bright. And I'm not trying to blind drivers that are coming up behind me so they can't see where they're driving. I just want it bright enough so they can see me a long distance off, and if they try and sit up my ass, they're going to back off pretty quick because this is going to be in their face. So, yeah, I need to... It's one of those I'm going to have to... It's not to actually get it on the bike in the dark and have a play around with it, you know, to see how bright it is. But I've got some little running lights coming for it as well. So, yeah, anyway, that's all for now. And thanks for watching. Catch you next time. Oh, just an additional look. This is it in a darkened room. So considering it's only flashing for about 40 milliseconds and it's still giving the camera enough time to pick up, it is so unbelievably bright. It is amazing, yeah. I might have to dim it down. Like I say, if I put a resistor in there rather than this constant current driver, I can dim down the brightness a bit, or it is a bit of a contender for a PIC, because then you can have it even when it comes on. It's still doing, like, say, sort of 1-2 kilohertz pulse width modulation. So, you know, but yeah, anyway, so thanks for watching.